Why can you see the things around you? It's because there's light. At night, if there's no lighting, if the sky is overcast or if there's a new moon, you won't see anything. The sun, stars, flames, and lamps all give out light. Objects that give out light are called luminous objects. Objects that do not give out light are called non-luminous objects.
The moon itself does not give out light. The moon is bright because it reflects the light that the sun shines on it. It is this reflection that we can see the moon. Most objects do not give out light themselves. We can see them because these non-luminous objects reflect the light that falls on their surfaces.
Why can you see the things around you? It's because there's light. At night, if there's no lighting, if the sky is overcast or if there's a new moon, you won't see anything. The sun, stars, flames, and lamps all give out light. Objects that give out light are called luminous objects. Objects that do not give out light are called non-luminous objects.
The moon itself does not give out light. The moon is bright because it reflects the light that the sun shines on it. It is this reflection that we can see the moon. Most objects do not give out light themselves. We can see them because these non-luminous objects reflect the light that falls on their surfaces. An example is the retroreflective material used on the uniforms of the police and on road signs. When the light from a torch or headlights falls on this reflective material, the material reflects the light back. The uniform and road signs can then be easily seen by drivers.
We know that light travels in a straight line. Make different shapes with your hands in front of a light source. You'll see lively images of dogs, ducks, and birds on the wall. If light didn't travel in a straight line, there would be no shadow. Over 2,000 years ago, the Chinese were already using a pinhole to create images. The way to do this is to fix a board of wood against a large window and make a pinhole in the board. A picture will then appear on the opposite wall. This is known as a pinhole image.
Both a pinhole image and a pinhole camera are based on the fact that light travels in a straight line. We can use a shoebox and a piece of tracing paper to make a pinhole camera. The light spot moves a great distance across the wall. That's the relationship between the reflected ray and the incident ray. Put a sheet of white paper on the table and place a ray box above it. The light beam from the ray box forms a bright line on the paper. Put a rectangular mirror in the path of the light beam, and the reflected beam will appear on the paper. Change the angle of the mirror, and the reflected beam will also change its direction.
Draw a straight line on the paper along the plane of the mirror. This is the position of the reflective surface. Use a few pins to locate the paths of the incident ray and reflected ray. Then use a pencil and a ruler to draw the incident and reflected rays on the paper as marked by the pinholes. The incident ray hits the mirror at the point of incidence. Draw a line perpendicular to the reflective surface at the point of incidence. This line is called the normal. The angle between the incident ray and the normal is the angle of incidence. The angle between the reflected ray and the normal is the angle of reflection. Use a protractor to measure these angles. We can see that the angle of reflection is equal to the angle of incidence. If we change the angle between the incident ray and the mirror, we find that the two angles are always equal. This is known as the law of reflection.
In a dark environment, use a light torch to illuminate a mirror and a piece of paper. Guess which of the objects is brighter? It turns out that the mirror looks dark, while the paper is very bright.
When light falls on a smooth mirror plane, the angles of incidence of all rays are the same. The angles of reflection will naturally be the same too. The light will then be reflected regularly. None of the reflected rays will enter your eyes. When a beam of light falls on a piece of paper, the light rays are reflected in different directions because the surface of the paper is not regular. We can then see the illuminated paper from any direction.
When we look at things, we are used to tracing the source of light from an object along a straight line. The candle we see now is only its image. The light from the candle is reflected by the mirror into our eyes. So we get the impression that the light comes from a point behind the mirror, which we call an image.
Let the divergent rays from a ray box fall on a plane mirror. Extend the reflected rays backwards to locate the image of the light bulb in the ray box. The reflected rays seem to have come out from this image, but in fact they have not. This kind of image is thus known as a virtual image.
This is a piece of flat glass set up on the table. I place a lit candle in front of this piece of glass and place a glass container behind the piece of glass. Now I fill the glass container with water. Remember, these two objects must be at equal distances from the flat piece of glass in a dark environment. When we watch from the side of the candle, we will see a strange phenomenon. The candle is burning underwater. This experiment shows that the object in front of a mirror can form a virtual image behind the mirror. The distance between the object and the mirror is the same as the distance between the virtual image and the mirror. Take two candles of the same size. Light one and put it in front of a piece of flat glass. Put the other unlit candle behind the glass. Move the unlit candle until it appears, from all angles, to overlap with the virtual image of the lit candle, so that it too looks as if it has been lit. This experiment shows that the virtual image and the real object are of the same size.
Have you noticed that the letters on an ambulance are written the wrong way round? In other words, they are laterally inverted so that the driver in front of the ambulance can read the word in its normal form when looking in his rearview mirror. Place a card with the word light written on it on the table. Stand a mirror on the card. When we look at the mirror, we will see that all the letters in the mirror are laterally inverted.
The image formed by a plane mirror is erect but laterally inverted. So the left hand becomes the right hand, and the left eye becomes the right eye. The image in the mirror sometimes creates interesting illusions. Because of gravity, you may not believe that I can lift both legs from the ground and float in the air. But how would you explain what you see now? A mirror can form an image. Two mirrors can form 2, 3, 4, or more images. These images are formed by the multiple reflections of light between two mirrors. An image is formed when light is reflected once by the mirror. The smaller the angle between the mirrors, the greater the number of reflections of light between the mirrors, and the greater number of virtual images formed. A kaleidoscope is constructed using this principle.
As light travels in a straight line, how can we see things beyond the wall? In ancient China, there was often a large bronze mirror suspended at an angle below the eaves of a house. If we put a basin of water on the ground, we can see the things outside the house by means of reflection.
I can't see the things behind this wall, but a periscope can help. A periscope is made of two plane mirrors of exactly the same size. The mirrors are placed at an angle at the top and at the bottom of a rectangular box, parallel to each other. The angle between each of the mirrors and the box should be 45 degrees.
Light goes into the box through the window at the top. The light rays turn 90 degrees at each mirror and go into our eyes. Moreover, after two reflections, the virtual image that we see is no longer laterally inverted. Periscopes are fixed in double-decker buses to allow the driver to see what's happening on the upper deck. Periscopes are also fixed in submarines to allow the crew underwater to see things on the surface. Why does a swimming pool look shallower than it really is? Why does a word seem larger when viewed through a block of glass? Immerse half a chopstick in water. Look carefully at the chopstick. Is there anything special about it? Why can you see the things around you? It's because there's light. At night, if there's no lighting, if the sky is overcast or if there's a new moon, you won't see anything. The sun, stars, flames, and lamps all give out light. Objects that give out light are called luminous objects. Objects that do not give out light are called non-luminous objects.
The moon itself does not give out light. The moon is bright because it reflects the light that the sun shines on it. It is this reflection that we can see the moon. Most objects do not give out light themselves. We can see them because these non-luminous objects reflect the light that falls on their surfaces. Yeah.